It started as a normal Wednesday evening. Families gathered for a national holiday. Children were watching movies. Restaurants were full. And then, at 6:04 in the evening, the ground beneath northern Venezuela moved in a way it hadn't moved in more than 126 years. A magnitude 7.2 earthquake detonated along the Caribbean coast, walls cracking, furniture flying, people sprinting into streets still wet from the afternoon rain. That alone would have been the worst earthquake Venezuela had seen in a generation. But here's the part that changed everything. 39 seconds later, a second earthquake struck, magnitude 7.5, shallower, closer to the surface, and significantly more powerful. Two massive seismic events separated by less than a minute. Scientists have a name for this, a doublet earthquake. And what this doublet revealed about the fault beneath Venezuela is something geologists have been warning about for decades, a warning that almost no one outside the scientific community was listening to. Venezuela does not appear on most people's mental maps of earthquake risk. The country sits in a corner of South America that rarely makes headlines for geological reasons. Most of the seismic attention in Latin America goes to Chile, Peru, Mexico, countries that hug the Pacific Ring of Fire, where tectonic plates collide and grind constantly. Venezuela's position on the Caribbean coast seems at first glance far removed from that kind of danger, but appearances in geology are almost always deceiving. Beneath Venezuela's northern coast runs one of the most geologically complex fault systems in the Western Hemisphere, the Bocano-Moron-El Pilar fault system. It stretches 1,300 kilometers along the country's northern edge, from the central Andes all the way through the northeastern coast, curving toward the island of Trinidad. This is where the Caribbean tectonic plate and the South American plate meet, not in a head-on collision, but in a sideways grind, a motion geologists call right lateral strike slip. Two continental masses moving horizontally past each other, accumulating stress, building pressure, decade after decade. The last time this system fully ruptured with this magnitude was in 1900. That earthquake, also along the northern coast, measured 7.7, and it caused catastrophic damage across the region. After that, the fault went quiet, not because the pressure disappeared, because the pressure was waiting. For 126 years, stress accumulated along the Bocano-Moron fault. Every year without a major earthquake wasn't a sign of safety. It was a deposit in a seismic bank account that could only ever end one way. And on June 24, 2026, that account came due. The first earthquake, the 7.2, struck at 10:04 UTC, roughly 168 kilometers west of Caracas, near the coastal town of Moron, at a depth of 22 kilometers. The shaking reached the capital within seconds, but scientists immediately recognized something alarming. The magnitude, the location, the fault mechanism, all of it matched the profile of a precursor event, a foreshock to something larger. 39 seconds later, that something larger arrived. The magnitude 7.5 main shock struck just north of the first earthquake, near the town of Yumare, at a depth of only 10 kilometers. 10 kilometers is shallow by tectonic standards. Shallow earthquakes don't have the luxury of deep earth to absorb their energy. That energy goes up, straight into whatever sits above it, and what sat above it was one of the most densely populated regions in South America. The USGS shake map registered intensity levels reaching MMI 8.7 in the most affected zones. That's classified as violent shaking. At that intensity, buildings don't just crack, they shift off their foundations. Walls that were standing during the first quake came down during the second. First responders who had run toward the damage from the 7.2 were suddenly in the middle of the 7.5. Caracas, 179 kilometers to the east, registered an intensity of MMY5 Taos, moderate shaking. That number understates what happened in the city, because at MMI5, older buildings constructed before modern seismic codes, buildings that had already absorbed the first earthquake 39 seconds earlier, react very differently than they would to a single event. Venezuela's building stock, particularly in lower-income neighborhoods, was not designed for sequential seismic loading. The second earthquake found every crack the first earthquake made and made them fatal. By Thursday morning, confirmed fatalities stood at 188. At least 1,520 people were reported injured. More than 157 people were still missing. Nearly 3,000 families were impacted by the combined events, and the USGS, using its pager rapid assessment system, estimated a 44% probability that the final death toll exceeds 10,000, a 30% probability that it exceeds 100,000. Stop for a second. Let that number sink in. Not a worst-case scenario buried in a footnote. A 44% probability, slightly less likely than flipping a coin and getting heads. That is the framework within which search and rescue operations were beginning on Thursday morning. The Simón Bolívar International Airport, Venezuela's primary connection to the outside world, sustained structural damage and was shut down. All arrivals and departures were canceled. Buildings collapsed in Caracas, in Trujillo, in Carabobo, in Aragua, in Miranda, and in the coastal state of La Guaira. A tsunami warning was briefly issued for Puerto Rico, the U.S. Virgin Islands, and the ABC Islands, Aruba, Curaçao, and Bonaire, off Venezuela's northwest coast. The warning was lifted within approximately an hour, but not before it forced coastal evacuations across multiple jurisdictions. Acting President Delcy Rodriguez declared a state of emergency. Interior Minister Diosdado Cabello went on state television and urged citizens to remain outside as aftershocks continued rattling compromised structures. The building really shook from side to side, said Roberto Gamas, a Caracas resident who described the main shock. Unreal. The force was incredibly strong. But here's the part of this story that most coverage missed entirely. This wasn't two separate earthquakes that happened to occur close together. This was a doublet, a specific seismic phenomenon where two large magnitude earthquakes occur on the same fault system or on closely related fault segments within a very short window. And doublets behave differently from single earthquakes in ways that matter enormously for damage assessment and aftershock forecasting. In a standard earthquake, stress transfers outward from the rupture point in a relatively predictable pattern. Aftershocks follow the Gutenberg-Richter relationship, a mathematical formula that allows seismologists to estimate how many aftershocks of a given magnitude to expect and over what time period. This forecasting is imperfect, but it gives emergency managers something to work with. In a doublet, the second event fundamentally rewrites the stress field created by the first. Think of it like pressing down on a bruised apple with one finger, and then immediately pressing down beside it with a second finger before the first bruise has had time to stabilize. The internal structure of the fruit, the fault system, experiences competing pressure fronts simultaneously. The aftershock distribution becomes harder to model. The areas of stress concentration shift in ways that standard algorithms don't fully anticipate. And crucially, the probability of a further large earthquake, a third event, increases in the short term in ways that exceed what a single earthquake of the same combined energy would predict. The USGS aftershock forecast, published within hours of the main shock, estimated a 2% probability that the M7.5 itself was a foreshock to an even larger event in the following week. 2% sounds small, but that forecast was issued against the backdrop of a region that had already produced two magnitude 7+ events in a single minute. In seismology, 2% on a catastrophic outcome in an area of 25 million people does not feel small. 25 million people. That is the population of Venezuela exposed to some degree of shaking from this event. Roughly 9 million of them experienced intensity level 4, enough to feel clearly, enough to wake people from sleep, enough to rattle unanchored objects off shelves. Approximately 117,000 people were exposed to intensity level 9, the level at which the USGS classifies shaking as violent, where heavy damage to most buildings is expected and partial structural collapse is probable. 117,000 people in the zone of probable structural collapse. That is a number larger than the entire population of a mid-sized American city. And those people were in a country where, as of May 2026, nearly 8 million people were already assessed by United Nations humanitarian agencies as being in need of assistance, before a single wall had fallen. The Altamira and Los Palos Grandes neighborhoods of Caracas saw what Interior Minister Cabello described as alarming situations, a phrase that, in the context of collapsed buildings and blocked streets, carries a specific weight. These are relatively affluent neighborhoods by Venezuelan standards. If they suffered this level of damage, the assessment of lower-income areas, where construction quality is lower and retrofitting essentially non-existent, may take days to complete. The economic projections are staggering. The USGS pager system estimated a 39% probability that economic losses fall between $10 billion and $100 billion, a 30% probability that losses exceed $100 billion, an amount that, according to upper estimates, could represent up to 20% of Venezuela's entire gross domestic product, wiped out by 39 seconds. And there is something else scientists are watching right now. Something that doesn't make the immediate casualty headlines, but that shapes the long-term risk profile of this event significantly. The rupture area of a magnitude 7.5 earthquake is typically estimated at 90 to 200 kilometers in length, but the doublet nature of this event, with the 7.2 and 7.5 striking in different locations along the same fault system means the total rupture footprint is likely larger than either event alone would suggest. Aftershock distributions, as they emerge over the coming days, will outline where the fault actually slipped and where stress has been transferred to adjacent unruptured segments. The Bocano Moron El Pilar system doesn't end near Umare. It continues east through Venezuela's most densely populated coastal corridor, through the metropolitan Caracas region, and onward toward the geologically complex zone near Trinidad. Scientists are now watching those eastern segments of the fault with extreme attention. A large earthquake on the western segment, like the one that just occurred, can transfer stress, a phenomenon called Coulomb stress transfer, onto adjacent fault segments, potentially moving those segments closer to their own rupture thresholds. The number seismologists will be watching in the coming weeks is the distribution of M4.0 and above aftershocks. If they cluster tightly around the June 24th rupture zone, the immediate risk to Caracas may be lower than feared. If they begin migrating eastward, if the aftershock sequence starts edging closer to the capital, that migration is the signal that stress transfer is actively reshaping the seismic hazard picture across the entire northern fault system. That answer may come in days, it may come in weeks, but it will come, and for the 25 million Venezuelans living above this fault, and for the 8 million already assessed as needing humanitarian assistance before this earthquake struck, the answer will determine whether what happened on June 24th was a catastrophe or the beginning of one. Subscribe to stay ahead of what's coming.